Equations with one solution, no solution, or infinite number of solutions. Most often in algebra and in math, we are looking for one solution. This is the default when we're doing problems. But there can be situations in algebra when you solve an equation and this is the answer or this is the answer. So we're going to do some problems here that demonstrate actually all three of these, but we're going to talk and focus primarily on equations with no solutions or an infinite number of solutions. This is the infinity symbol. So the first thing when we have an equation and it involves variables is we want to change the subtraction parts of the equation to addition, which means that we're going to change this sign to an addition and the number or the variable following it to the opposite of whatever it is. So we're going to change this to an addition and this is going to be a negative x. The second thing we're going to do is we're going to look for things that are the same and group them together on the same side of the equal sign. So that means we're going to put numbers with numbers and we're going to put x's with x's. So on the left side I have an x and I don't have any other x's, but I do have a positive 3 and a positive 7. So I'm going to put those together and that's going to give me a positive 10. On the other side, I can see that I have two x's and I have a negative x. When I group these together, 2x and a negative x is just going to give me 1x. These are positive x's. This is a negative x. So I'm going to end up with, if I drew it out, here are my two x's. Here's my negative x. These two are going to make a zero pair. So I'm left with just one x and I have plus a negative 10. Now in algebra we always want to try to get x's on one side and numbers on the other side. So I can see that I have x's on both sides and numbers on both sides. So my number of x's that I have is the same, and so it doesn't matter if I try to get my x's on the left or my x's on the right because I only have one x on each side. So I'm going to add a negative x to each side to create a zero pair, because if I do something on one side I have to do it on the other side. These cancel out and what I'm left with is 10 is equal to negative 10. Now when I look at that I say this is an untrue statement. In mathematics this is not true. And when I have an untrue statement, that means that there is no solution to this problem. Where this, when I put something in for x, that the quantity on the left-hand side will be equal to the quantity on the right-hand side. There is no one number that I can put in for x and have this whole thing be equal. So this, when I get an untrue statement in the end, that means that there is no solution. This is the correct answer to this problem. No solution. I actually had a hint right back up here. You'll notice that I had the same number of x's on each side of the equal sign, and then my numbers that I had were not the same number. And so I had an idea up here that when I have the same number of x's on each side of the equation, and my numbers are different, that I'm going to get an untrue statement, which means there's no solution. So sometimes along the way we can get an idea of what our answer is going to be. Let's go ahead and look at another one. This problem involves parentheses, so I need to distribute this 3 throughout the parentheses, which means I'm going to multiply. When a 3 or a number is right next to parentheses, it means multiply everything inside the parentheses by that number. So 3 times x means 3 x's. My operation or my sign comes down, and 3 times 4 is 12. On the other side, I have 3x and I have a 12. At this point, I can see that everything on the left-hand side is exactly the same as the right-hand side. My operations are the same. The values, the positive or negatives on each of the terms is the same. That means that no matter what I put in for x, it's going to be a true statement. But this would be true no matter if I put in 1, I would have a true statement. I would have 3 plus 12 equals 3 plus 12, and I would have 15 equals 15 when x is 1. What about if x is 0? If I put 0 in, and I'll do that over here, 3 times 0 plus 12 equals 3 times 0 plus 12. 3 times 0 is 0 plus 12. 0 plus 12, 12 equals 12. This is a true statement when x is 0. I can keep inputting values for x and I will get true statements. In other words, the left-hand side will equal the right-hand side. When I get statements in the end where I have the exact same number on both sides or the exact same number of variables, like 4x equals 4x or 8x equals 8x, that means that I have an infinite number of solutions. I can put anything in for x as long as I put that same value in on both sides, and I'm going to end up with an equivalency. I'm going to end up with both sides being equal. So this is a situation where I have an infinite number of solutions. And a couple of things to notice here. My x values are exactly the same. When I have x values that are exactly the same, and I also have my constants, the numbers that are exactly the same, at this point I know that I'm going to have an infinite number of solutions. Remember back up here, my x values were the exact same, but my constant or my numbers were not exactly the same. So that resulted in no solution, and this results in an infinite number of solutions. Let's look at this one. 5x plus 8 equals 2x minus 1. So I'm going to change that to plus a negative, and then I'm going to go ahead and solve this. I can see I have x's and numbers on the left, I have x's and numbers on the right, so that means I want to try and get all of my x's on one side and all of my numbers on the other side. And since I have more x's on the left, I'm going to try to keep all of my x's on the left. So I'm going to add negative 2x to each side, which is the same as subtracting 2x from each side. And I have 3x plus 8 equals, these are 0, a 0 pair, and then I have plus a negative 1. So now I have all of my x's over here. Great. But I've got a number with it. I want to get that number over on the other side. So I'm going to add the opposite, and I'm going to get that 3 x's are equal to negative 9. Now, 3 times what number would equal negative 9? That means that I have to figure out what this is, and the algorithm is we divide each side by 3. We divide by this number, and a negative divided by a positive gives me that x is equal to a negative 3. So in this situation, I did get one answer. And if I go back up into my original equation and check it, 5 times negative 3 is negative 15 plus 8. That would give me negative 7 on the left-hand side. And when I put in negative 3 for 2x, I would get negative 6 plus negative 1. So that would give me negative 7. So negative 7 does equal negative 7. I just have one answer here. Let's go back and look at our values here. Notice that this time I have an unequal number of x's on the two sides of the equation. When I have an unequal number of x's on the two sides of the equation, that means that I am going to be able to get a single x all by itself in the end. And that's a big clue to me that when I see that situation, I'm going to have one answer. And so this is my answer. So let's use what we've learned up here with no solutions, infinite number of solutions, and one solution to look at the last three problems. Here again, I have x's on both sides and I have numbers on both sides. So I want to try and get my numbers all to one side and my x's all to one side. And I can see that I have more x's on the left than I do on the right. I also notice that I don't have the same number of x's. So when I don't have the same number of x's, I'm probably going to have one solution. I'm probably going to be able to figure out what x is in this problem. So I'm going to add the opposite to both sides. So this becomes 0, and over here I'm going to add a negative 2 and 5/10 x to 3x so that I can get my x's all on the left-hand side. So this is going to give me 0 and 5/10 x. Now my number stays there. 1 and 5/10 is equal to, these are gone, 4 and 7/10. So now what I do is I want to get all of my x's on one side. I have that, and my numbers over on the other side. So I'm going to add the opposite. Going to use my additive inverse property. And when I do that, I get 0 and 5/10 x is equal to 3 and, let's see, 2/10. So now I want to just figure out what number times 5/10 is going to give me 3 and 2/10. So this is where I'm going to use my calculator. I'm going to divide each side by 5/10, not 5/10 x, because I want my x to stay here. I want my x to stay there. I just want this coefficient in front of it to not be there. So these are going to divide out to 1, but I have to figure out what this is. So 3 2/10 divided by 5/10 is equal to 6 4/10. So x is equal to 6 4/10. I have one solution here. And that makes sense because when I look back up at my problem, remember I had an unequal number of x's on each side. That's what would lead me to believe that I have a solution. Two more problems. We have parentheses here, so we're going to use the distributive property. 3 times x is 3x, plus 3 times 2 is 6. This is equal to 3x plus a negative 6. So you can see here I have the same number of x's on each side. But my numbers are different. I have a 6 and I have a negative 6. This is going to result in these x's canceling out. And we can go through the process of showing you that. Those sum to 0, and I'm left with 6 is equal to negative 6, which is an untrue statement, so I have no solution for this particular one. Last problem. I'm going to go through and change these to plus and negative here. And on the right hand side I can group my x's together. So I'm going to have 9x plus a negative 4. And on the left hand side I have 9x plus a negative 4. At this stage, when my left hand side is the exact as my right hand side, I know that I have an infinite number of solutions.